This is exercise 5.2, Q2, odd numbered problems. Again, the even numbered problems are assigned for homework, so I'm going to do some of the odd numbered problems here. This new section, 5.2, has added a new rule called conditional elimination. Remember, eventually we'll have an introduction and elimination rule for every operator. Okay, so we're sort of slowly working up to that. These four here rules we worked with last time in exercise 5.1. So this is the only one added. Notice its elimination rule is for the conditional, and it takes two inputs. In other words, to apply this rule, you need two things. You need a sentence where the main operator is the conditional, and you need the antecedent of that conditional. Right? The antecedent, remember, is what comes before the horseshoe. As output, then, you get the consequent of that same conditional. Consequent is what comes after the horseshoe. Okay, so again, we need two things, conditional, antecedent, and what we get out is the consequent. Okay, so I've already set these up vertically. Remember that the premises are separated by commas in the text, and the conclusion is separated with this 3-dot symbol. So you have to make sure you list the premises on lines, numbered lines, so that you can do the derivation. Okay, so here we got a conditional. We've got a P by itself and Q by itself, and we want to get R. Now R is the consequent of this conditional. So again, the conditional elimination rule gives us the consequent of the conditional. But to get that, we need a conditional and the antecedent. Well, we've got a conditional, but we don't have the antecedent. We need the antecedent P and Q. We can get that easily enough using our conjunction introduction rule on sentences 2 and 3, or lines 2 and 3. So remember, the conjunction introduction rule says if you have a sentence P and Q, you can put them together into P and Q, and that's exactly what we did. Okay, so now we have the antecedent of the conditional, so we can get R, and now this is conditional elimination 1, 4. So sentence 1 is a conditional, or line 1 is a conditional, line 4 is the antecedent of the conditional, so that gives us the consequent of the conditional. So number 1 is just 2 steps. Number 3, we need not B for our conclusion. Here it is, here is the consequent, so if we can get not A, we could get not B by conditional elimination. But we don't have not A by itself. We can get not A by itself, though, by doing a disjunction elimination, right? So we can get not A by disjunction elimination of 2 and 3. Line 2 is a disjunction. Line 3 is the negation of one of the disjuncts. So that gives us, as a result, the other disjunct. So remember that. Disjunction plus negation of one of the disjuncts gives us the other disjunct. Okay, so now we have line A, or not A by itself, and now we can get not B by conditional elimination of 1 and 4. Okay, so notice that when we're doing these derivations, we're sort of working in two directions. We're looking at our premises and seeing what we can do, what rules can we apply. But we're also looking at our conclusion and seeing how do we get there, right? Because we first looked and we saw we need to get not B. We saw not B is here as the consequent of a conditional, so that we need to get the antecedent of the conditional, and then we saw how to do that. So when you're working on these derivations, you should be working both ways, applying rules to the premises as they apply, but also keeping an eye on the conclusion to see where you're going. Okay, so 5 we have, again, we need not R. Not R occurs here as the consequent of a conditional, so if we could get Q by itself, we could get not R by conditional elimination. We don't have Q by itself, but here it is in a disjunction, so we can get it out of the disjunction with disjunction elimination. So we get Q by disjunction elimination of 1 and 2, right? 1 is a disjunction, 2 is the negation of this disjunct. The negation of not P is not P. So that leaves us with Q. And again, like we just said, we needed Q to get not R by conditional elimination then of 3 and 4. Line 3 is a conditional, 3, and line 4 is the antecedent of that conditional. That's why we write 3, 4. And as output, we get the consequent, which is not R. Okay, this number 7, we need to get B. B is here in a disjunction, so we could get B by itself if we had not O. We could do a disjunction elimination. Here's not O here in a conditional as the consequent, so if we got the antecedent, we could do a conditional elimination to get not O. And we can get the antecedent by doing a conjunction introduction. We get L and M by conjunction introduction of 1 and 2. Remember, that's the rule that says if you have a sentence on one line and another sentence on another line, you can put them into a conjunction. So then now we have that. We can get not O by conditional elimination of 3, 5. Line 3 is a conditional. Line 5 is the antecedent, so that gives us the consequent. And we needed not O to get B, and that's by disjunction elimination of 4 and 6. And that's our conclusion, so we're done. So again, notice how we looked ahead to what we needed. B is here, so disjunction elimination, but we need not O. Not O's here, so conditional elimination. Put together this, so we have the antecedent. So it's sort of working backwards in your head and then working forwards in the proof. Okay, last one, number 9. So here we need a disjunction as our conclusion. We've got conjunction, disjunction, conditional. So how are we going to do this? Well, if we get W by itself, we could do a disjunction introduction to get W or X. And here's W by itself in a it's not by itself, it's in a disjunction. So to get it out of the disjunction, we need not Y. Here's not Y here, but it's the consequent of a conditional, which we would need to get not X. And now here's not X down here. So not X by itself, we want. That's conjunction elimination of 3. Conjunction elimination says if you have a conjunction, you can have either conjunct by itself. We want not X though because we want to get not Y by conditional elimination of 1 and 4. Line 1 is a conditional. Line 4 is the antecedent of the conditional, and that gives us as output the consequent. Now we can get W by itself by disjunction elimination of 2, 5. Line 2 is a disjunction. Line 5 is the negation of one of the disjuncts, so that gives us the other disjunct. And then our last step, W, V, X by disjunction introduction of 6. Remember, disjunction introduction says if you have any sentence, you can put it into a disjunction with any other sentence. So we have the sentence W here on line 6, so we can put that into a disjunction with any sentence by disjunction introduction, and since that's our conclusion, that's what we choose, X. Okay, so I was saying last time I got cut off a little bit at the end about the numbers. Like, how do you know how many numbers you need after the rule? And the way you tell is by how many inputs the rule requires. So in conjunction introduction requires 2 inputs, so it's going to have 2 numbers after it. Right? Also, disjunction elimination requires 2 inputs, so it's going to have 2 numbers after it. Here's disjunction elimination. And now conditional elimination also requires 2 inputs, so that's going to have 2 numbers after it as well. Now these 2 rules, conjunction elimination and disjunction introduction, have only 1 input. Right? So they're only going to have 1 number after them. Right? So let's see. Conjunction elimination 3, disjunction introduction 6. Right? So again, think of the premises here as inputs and the conclusion as output. So to apply the rule, you need both of the inputs in the premises somewhere to get the output. Okay. And the introduction rules introduce the operator, whereas elimination rules eliminate the operator. So anytime I have a rule that is an introduction rule, right, I should look over here to my left and see whatever operator is being introduced. So this says conjunction introduction. So on that line, there better be a sentence whose main operator is the conjunction, because that's what the rule says I'm doing. I'm introducing that that operator, right? Same with disjunction introduction, right? I better look over here and see as a main operator a disjunction, because the rule says I'm introducing a disjunction. That's what that means. Elimination rules, on the other hand, I should look at the numbers. So here's conditional elimination. I better find on line 1 or line 4 a sentence whose main operator is a conditional. And indeed here I find that on line 1, right? Because this says I'm eliminating a conditional, so that means there must be a conditional that I'm eliminating in one of these numbers. So same with disjunction elimination of 2 and 3. So I better look on line 2 or 3 and find a sentence whose main operator is the disjunction. Let's see, conjunction elimination. Again, I better look on line 3 and find a sentence whose main operator is a conjunction, and that's indeed what I find. Okay, I hope that helps. I'm going to do some from exercise 5.3 next.